All right, here's our second talk for today. The speaker for today is Aiden Hamade. He's not a graduate student. He's a senior. He's a senior. Well, that's good. We like to have undergraduate students do the presentations as well. So here's the title of the talk, Side by Side in the LLM powered political bias system. You have 30 minutes. Okay, we'll take the last 5 minutes for the Q&A. All right. So let's welcome our second speaker for today.
All right. Hello, everybody. My name's Aiden Hamade. I'm here to show you guys SideBySide, which is a project I've been working on under Vikram Gazula and Jim Griffoon. Thank you guys for all the help. It's an LLM-powered political bias system. So we're going to talk about political bias in the media, and then I'll talk about my approach, my data pipeline, how I'm using my articles. I'll give you guys a demo, and then we'll talk about limitations and conclusions. So let's start with political bias. Thanks to the internet, information is more accessible than it's ever been before, and an unfortunate consequence of that is that anyone can really provide that information, and it's difficult for the average reader to determine the accuracy or objectiveness of that information. So that becomes a pretty serious problem in the news industry when events are happening all over the world and reporters are allowing their own biased judgments to influence how readers make or formulate opinions about those events. So this chart on the right is showing some research done by the Pew Research Center, where they were investigating how well people could tell the difference between factual and opinion news statements. And they saw that only about a quarter of them could identify all 5 factual statements, and only about a third could identify all 5 opinion statements, which kind of gives some insight into how serious of a problem this could be if everyone starts spreading biased information. When you read a news article, you expect the information to be true, and even if everything is true, bias still comes through the wording or semantic nuance of the text by the author, coverage choices, and influence from publishers. Political bias is also a very complicated issue because it's based on subjective interpretations of statements. So it's difficult to determine whether or not something is biased, and if it is, how biased. So there are 3 main ways that leading organizations have been using to detect bias. For a long time, and still today, we rely on expert analysis and community feedback. As natural language processing technologies have improved, people have begun to use those to kind of determine whether or not text is biased. So by training a model on a large data set of article text and labeling them as left or right-leaning, people have created models with up to about 95% accuracy in detecting bias, but there's an issue with NLP models. They are very susceptible to keywords. So when I was working with one model that claimed about 90% accuracy, I fed an article text into the model, and it returned a result of it's 73% confident this is a right-leaning source. I changed the first word in that text to be CNN, and it gave me a score of 99% left-leaning. And then I changed the first word to be Fox, and it said it was 87% left-leaning. So that kind of gives some insight into how difficult it is to trust some of these NLP models. So that could be happening because during the training process, the model saw that a lot of articles that are labeled as left-leaning included words like CNN and Fox. So it made that association. When it sees these keywords, this is probably a left-leaning article, without really understanding the context of how the words are used, which leads perfectly into why LLMs, or large language models, are proving to be one of the best ways to predict article bias right now. So LLMs use something called transformer attention, which assigns weights to every word based according to its relevance to the LLM's current task, which allows these LLMs to create these long-range dependencies and understand how words are being used in the context of small chunks of text, as well as the context of the full article. So if we're dealing with an article that's maybe more satirical and it's using right-leaning words like Donald Trump and border protection, but the author is like disagreeing with those things, then a large language model will recognize that it's using right-leaning words or keywords, and then but there's like a negative tone involved, so it can assume that it's a left-leaning source, whereas an NLP model may just see those right-leaning keywords and say, okay, this must be a right-leaning source. So in order to combat media bias, there are a few companies that have been creating tools like rating systems to help people become more aware of potential bias in their media. The three most notable organizations are All Sides, Media Bias Fact Check, and Ad Fontes Media, who all rely pretty heavily on expert analysis, community feedback, blind surveys, and they are beginning to use more AI and machine learning techniques. So they assign all of these scores at the publisher level, and then Ground News is a separate organization. They act more like a news outlet, and they use these scores from All Sides, Media Bias Fact Check, and Ad Fontes to kind of pull in articles and use those scores to say this is a left-leaning article and say how people from each side, I guess, are reporting on things. But there's a pretty big issue with how they're doing that, because all of those scores are assigned at the publisher level rather than the article level. So for example, all three of these organizations say that CNN is a left-leaning source. So anytime Ground News pulls in a source from CNN, they will tag it as left-leaning, even if the actual article itself is more central or even leans to the right. So Media Bias Detector is a new tool from the University of Pennsylvania. It's a new tool from the University of Pennsylvania that shows us that just because a publisher tends to lean towards a certain bias, every article is unique, and publishers publish articles with varying amounts of bias from across the spectrum. So while the publisher can introduce bias by deciding what news to cover, the author is the one who actually introduces that bias through wording, and Media Bias Detector is able to extract these article-specific bias scores by using LLM's ability to analyze full articles while also understanding the context of the current American political system or scene. Media Bias Detector is a great tool if you want to see how many biased articles some of the top publishers are releasing, but they don't exactly show you what makes those articles biased, which kind of leads into why I've decided to create SideBySide. So most of these tools provided by organizations are blocked behind paywalls. They score bias at the publisher level rather than the article level, and they make it difficult for readers to see bias present in specific articles. So with that in mind, I created SideBySide, which is an automated LLM-powered political bias system. The goal was to build a tool that helps users become more aware of bias in the news by highlighting key points from left and right-leaning coverage of current events. In order for me to do this, I need to identify, categorize, and analyze articles from current events. So the first challenge is to have articles to reference when someone queries about a current event. And it's important that I store those articles in the back end rather than scrape the web for articles each time a query is made, mostly for the sake of speed when someone's using my tool. Secondly, once I have articles, I need a way to reliably assign bias scores to them. This is one of the most difficult parts or aspects of this project because there are essentially no tools right now that will automatically generate a bias score for a specific article beyond the LLM prompts used by Media Bias Detector. The last challenge is to analyze articles and highlight specific parts of those articles that to show the user where the bias exists in the article and kind of what it looks like. So my system needs to be able to cite its sources and allow users to actually see those biased articles. So we can start by talking about my data pipeline, which tackles the first two problems of gathering articles and extracting or assigning bias scores. So my tool needs to have up-to-date current events because that's what people are looking for when they're using this tool. Fortunately, there are plenty of online tools that help me to identify articles and associate them with a current event and then process those articles. So since this project is more of a proof of concept, I chose to test with only a few current events, and I'm using something called News API, which is a platform that gathers news data from all around the world and allows me to extract top headlines and associate that with an event. Unfortunately, they don't give me full article text, so I have to feed these URLs into a Python package called newspaper3k, which is really nice compared to some other web scraping tools I was using, because other tools would get the ads stuck inside of the article content, or the article text, and I don't want to feed those or use those at all. They also have some NLP tools that are really nice and allow me to summarize those articles. But once I have that summary, I can take it to another tool called Event Registry that works directly with News API to associate an article with a current event. And then once I have that event ID, I can then grab multiple articles all associated with that current event. And then once I have enough articles about a certain event, I can feed the full article text into a large language model that generates a bias score for each article. And here I'm using the exact same prompts that Media Bias Detector is using, and that was really the only way that I could reliably generate those bias scores. I'm also taking some metadata about each of the articles, like the event ID, the publisher, and the release date. And those are put together into one big JSON document, and then they are stored into a vector database. So you guys are probably wanting to know how I'm prompting those LLMs to generate the bias scores. The prompts are, this is the exact same prompt that is on Media Bias Detector's methodology. You could see a bit of the prompt engineering at play here. So they start by addressing an overall task, telling the LLM it's about to read a news article, and they clearly separate the content of the article from anything else in the query, and then they give a specific task followed by specific instructions. And they also give the format of how they want that response returned to them, and that is something called one-shot learning. So there's kind of a double-edged sword with LLMs and their creativity, because I'm sure most of you guys have used tools like ChatGPT. If you ask it to do the same thing twice, it's going to at least give you slight differences in its responses. So that's nice when you want to write an email and you don't like the way it was worded the first time, but when you're using LLMs and expecting a certain format of a response so that you can parse those outputs, it's kind of a pain. So by using one-shot learning, I can get that formatted response as I need it. Sometimes that doesn't always work entirely, so I can change a parameter called temperature on these models, and by setting a lower temperature, their outputs are more predictable, and I don't run into those issues. So now that you guys know how I'm getting articles and assigning their bias scores, we can talk about how I'm actually using them. So everything starts with a user query about a current event, which can be just a few words describing a current event, like tariffs or the Ukraine-Russia war, just as an example. And then that query is passed to a vector database, which will perform a similarity search to identify the most relevant event stored and those articles. And once we know the event, we can retrieve the left-leaning, central, and right-leaning articles. And then those articles are passed along to large language models, which are tasked with finding the most partisan points across the articles. So each group of articles is sent to an LLM with different system prompts. So the left-leaning articles are passed to an LLM that's told it's a left-leaning reporter that recognizes democratic values, and its job is to extract those most partisan key points into a few main points, and it needs to maintain the semantic nuance or wording and the biased tone that's present in those articles. That process is repeated for the central and right-leaning sources as well. It's also important to mention here that LLMs are known to inherently have a slight left-leaning bias, and that's just because they're trained on massive amounts of data, and I've already mentioned it's pretty difficult to determine whether or not something is biased unless an actual human or an expert is reading through that. So some of that training data, it's difficult to prove that your entire training set has no bias present in it. So to kind of work around that slightly, I chose to use open source models that have had their guardrails removed. So usually the guardrails, the point there is that they don't allow the LLMs to provide harmful information to people, but there are also some guardrails in place that prevent them from like spreading misinformation or giving biased responses. So by getting rid of those guardrails, the hope is that the LLMs can do what I'm asking them to do. All right. So this process is kind of where my entire system becomes a retrieval augmented generation system, or RAG system, rather than any other typical large language model system. So the vector database is essentially an attached knowledge base for the LLMs. So when someone asks an LLM a question, the question goes to that vector database first, and then it will prepend anything that it finds in the vector database. It prepends those documents to the actual query that is sent to the language model. So instead of just saying, tariffs, we have article, article, article about tariffs, and then summarize, do some bias analysis, extract the key points about this specific thing. And that's really essential to the project because LLMs are trained on a lot of information and they know things like who the current president is and what the US political scene looks like, but they're never going to know something that happened yesterday or 15 minutes ago unless they're searching the web, but that would take forever and it would just add latency to this project. So by having that attached storage full of documents from specific events, my system can quickly retrieve those documents and let the LLMs do their jobs. All right. So the last step in the process has to do with analyzing the key points that are generated by the LLMs. Left and right key points are passed on to a different LLM, which is responsible for extracting wording choices and phrases from the summaries that exhibit bias and explain why those wording choices express bias. So I chose not to pass in the central point key points because they're supposed to serve as more of like a ground truth about the current event, and I didn't see much of a point in having the LLM analyze those statements and explain why it's not biased. The point of the project is to kind of look at what bias looks like and help people identify that. So once the LLM is done analyzing these key points for bias, the 3 key points associated with each side and the bias analysis are shown to the user where they can then do their own investigation and learn more about what bias looks like. So here is just the task. This picture is just showing the task for the central model, but when I created the prompts for the LLMs that are extracting key points, I formatted the prompts in a similar way that Media Bias Detector did because, they explain that, the way that you format these prompts matters, and by doing it in this way, we can get better responses. So I start by giving the LLM an identity and a political affiliation, so I tell them that they are good at analyzing bias and they align with, left, central, or right, so that they are reading all of these articles from that perspective. And then across multiple messages, I pass in each of the articles that we grab from the vector database, and then I give it this specific task with specific format for how it should be responding. Here are the prompts, or this is the prompt for the bias analysis LLM. So once I have all of those key points and we pass it on to that final language model, this is what its system message looks like. So I tell it that it's an assistant and it's really good at evaluating political bias, and then I clearly separate out the left-leaning text and the right-leaning text, and then I give it a very specific task, and then here I use one-shot learning where I'm showing it exactly how I expect that response to be structured. All right, so now that you guys know how it works, I can show you this video kind of demoing what the project looks like. So I type this query, Trump car tariffs, because that's just something that has been going on. I think I picked those up about 2 weeks ago. And right now, it is going into the vector database with this query Trump car tariffs. It identifies an event, and then it passes anything associated with that event that has a left-leaning bias is sent over here. And sorry, these should say left, central, and right. But that process is repeated for all three of them, and then you can see these main points that are extracted, as well as these specific sources. And then down below, this video will start again, there is the bias analysis. So you can see it extracts a specific phrase from the left perspective, and then it tells you the bias indication. So it's saying the phrase uses specific dollar amounts to illustrate potential price increases, which might resonate with left-leaning audiences who are sensitive to economic impacts on individual consumer costs. So that's what that looks like. There's right analysis below as well. So now we can talk about some limitations and conclusions. So bias scores obviously are fairly difficult to verify, and the LLMs were the best way for me to get bias scores. The NLP methods obviously give me inaccurate scores, and they're susceptible to those keywords, so you can't trust those too well. I don't have a team of experts that can analyze a large amount of documents and assign bias scores to things. So yeah, if I'm using one LLM, if I give it that specific system prompt and those articles, and I give it the exact same task, but if I'm using different models, they could assign different bias scores just simply based on how they've been trained. So that's another limitation of the project. And also just using those news APIs and event registry, there are API costs. I have a free account, so I'm kind of limited in terms of how many articles I can grab. And obviously, it is computationally expensive to run 4 large language models, so the system runs a bit slowly. I'm sure you guys saw that lag a little bit in the demo. All right, so to talk about some conclusions, it's clear that there needs to be some sort of benchmark for bias scoring. The different organizations, they all use different scales. So I believe All Sides is on a scale of like -6 to +6, -6 being like extreme left-leaning, and then Media Bias Detector uses a -5 to 5 scale, and then Media Bias Fact Check kind of just says this is left-leaning, this is right-leaning, things like that. Yeah. So All Sides actually has recently released a tool that can, if you pass in a specific article URL, they will assign a bias score to it and kind of give like a brief synopsis of why it's biased. But it's extremely new and extremely limited, so I couldn't really use it for my project. I'm sure in the future, if they set up an API for it, I would be using that to assign my bias scores, because I'm sure they have a much more robust system to do that. But yeah, I was limited to like 30 articles per month, and I was dealing with more articles than that. Yeah. LLMs also do a really good job of maintaining bias. They're finding those key points. So if you actually go into the sources that those key points are based on, you'll actually see like almost verbatim some of the things that are being extracted. So it's nice to know that those aren't being hallucinated. And there are definitely ways to improve this project and like take it further by allowing people to submit links to their own articles. I could do something like what All Sides is doing with their media or with their bias checker, and I could of course scale up the number of events that I'm dealing with. So yeah, thank you guys for listening to my presentation.
We have a few minutes for questions.
It's on. It's a little hot, so you may have to adjust.
Hi, this was very interesting, but I have 2 questions. First is, from my experience, I know that most, a lot of articles are behind the paywall, like, New York Times, pretty much everything, right? So are you able to get to those things, or is this limited to like free for all kind of articles?
That's a pretty good question. Sometimes when I was using Newspaper 3K to go and scrape the article, I think if it's stuck behind a paywall, it just won't get access to it. I think sometimes it is able to bypass that paywall, but I don't want to use those sources as much. So I only know if I get like a return error in some way. But yeah, I think Newspaper 3K has like some sneaky tricks to get past a lot of paywalls. So that's just what I've been using.
I see. My second question is, in that, I guess that was the kind of architecture diagram, you had an orange dotted line where RAG does. So, and I remember the LLMs are extracting or, summarizing, coming up, generating key points and so on. That's not run every time user query comes in, right? That's already, because if you think about it, that's static in some ways. So is that, those key points and so on, are they already stored in a vector database, or?
You're entirely right about that. Since this was a proof of concept, that's kind of just how I was running things. But if I were to scale up, it obviously would not be ideal to have to, especially if I'm dealing with more articles, because in this project I was dealing with K equals 3 documents. So I was extracting 3 documents per event, per side, if those 3 documents existed. If I'm dealing with 100 articles from one side, I would obviously want those key points already extracted and those saved somewhere so that those can just be passed into the final bias analysis. And anytime someone goes to look at that current event, they are already there, ready for them. So you're entirely right. If I scale up, I would definitely need to do that for the sake of computation and speed. But yeah, for this, it was just a proof of concept, and I was regenerating them every time.
Okay, thank you.
Thanks.
Behind you. I'm sorry. Anybody else? Questions? Oh, here we go.
Hi. So I'm just curious, are you actually, let me put it in this way, if you are looking for a question that is actually really new, and the LLM is actually if you're using ChatGPT, and that is actually not trained on that data. So are you even getting into ChatGPT, or are you just looking into your RAG system? Are you getting my point?
Would I be asking the LLM about that event without the documents at all?
No. I'm asking that sometimes I also worked on RAG, so sometimes actually it is not needed to use the API call. That's what I'm saying, So have you anything in I know you're doing a proof of concept right now, you're in that stage. So do you have anything in your system that if a question is asked and it should not get into the ChatGPT API, is there anything you have there?
Right. Okay. Yeah. So I'm not actually using ChatGPT at all. I'm using Olama and running the.
Which LLM? If you don't mind me ask,
I'm using Queen 3 billion, and it's called the obliterated model.
Okay.
That's the process.
Okay, makes sense.
Removing the guardrails.
Okay.
Yeah.
Okay.
So.
Yeah.
Okay.
You have a question?
Yes, we are actually working on UK library, and also that we are working on a project a grant on dialogue system. So yeah, I was curious. I actually.
Yes. I believe that you also have a question, right?
Okay, thank you. I loved your presentation. I think, correct me if I understood it wrongly, but you were saying that you grabbed the articles from this site, you use the scraper to kind of grab the articles, and you summarize them, and then you pass it to the LLM for the bias analysis, right?
No, I'm passing full articles to the LLMs. I was using the summary because Event Registry has a nice tool where I can pass in a large chunk of text, and they will identify a specific event based on that chunk of text. So instead of, I think that maybe it wasn't a large chunk of text. Maybe I needed less text. So that's why I summarized them. And then I grabbed the event that first article was related to. So I grab a top headline, which is one specific article. I summarize it. And because that doesn't come to me with the event for some reason, even though News API and Event Registry work together. But I would take the summary of that first article to identify an event, and then I find more articles based on that event. And then those full article texts are eventually passed on to the
I see.
LLM.
So it's kind of like you grab a random article and then you summarize the article to identify an event out of it and then use that event to
Find more
okay.
articles.
Okay, okay,
Yeah.
got it, okay.
Thank you. Oh, here you go.
Thank you for your presentation. So my question is that did your experiments involve any fine-tuning of LLM?
No, they didn't. Since I have this attached knowledge base, I kind of just trust the general knowledge of the LLM. But you are right, like that is another expansion of this project. If I fine-tune these models on like an up-to-date current what's going on in America politically, I think that they would do a much better job of identifying at least what values each side has so that they can actually identify like what the biased or partisan points are in that article. So,
Right. So how large is your current database?
the current database, I mean, I worked with 3 different current events, each of which I had about 10 to 20 documents for each event. So less than 60 articles is what I'm dealing with. You're right though, like if I'm storing full article texts as a document in that vector database, I think that search or retrieval from the vector database would take too long if I scale up to like thousands or tens of thousands, however many articles. So that would definitely need a different approach. And I've thought about that more because I don't know how necessary the vector database is if we think about it in that way. Like if I have so many articles, it would probably be less efficient to try and find the documents that are in the vector database, where I could instead just take the user query and then pass that over to event registry to identify the event that it's about. And then in some regular database, I could just grab articles that are from that event. So
Okay.
the similarity search is kind of not necessary anymore at that point.
Thank you.
Hello, thank you for presentation. So I have one question. So when you are, I think you are using an open source language models. So I guess you can also calculate a confidence when you're getting the score. So do you like use such a thing like if the model is giving a score, you can get a confidence using like log probabilities or those kind of things to be like confident that this score that the model is giving is actually confident. And so for example, if a document is getting a score of like -5, but the model is not confident, you can just remove it. Can you do such a thing or yeah, that's my question.
That is a good point. I guess I didn't look too deeply into confidence scores. That's something I would definitely need to do more research about. I think that's a good point though. I mean, inside of all of my models or the system prompts, I explicitly told them if you don't recognize any bias, simply don't say anything, like return an empty JSON. Because if there's nothing to talk about, then there's nothing to talk about. So, I mean, how well do the models follow that certain instruction? I'm not sure. So confidence is definitely something I should be looking into.
Okay.
Yeah,
Thank you.
That's a good question, but you are forbidden to ask more questions. All right, so thank you very much.